scientists have theoretically proved the existence of wormholes. As we have discussed in part 1 of this video about wormholes and their existence, using Einstein equations and space-time relativity. Everything is attracted towards the black hole. Everything will be attracted towards it and will flow through this wormhole. It will go through this tunnel. But the next question is, what will happen on the other side of this tunnel? If there is a black hole on the other side, there will be no way out of this tunnel. You will be trapped inside it. Basically, this wormhole will not be a tunnel. Welcome again to Mr. Dar videos. Here comes the entry of white holes. Once again, white holes are a concept that has been proven theoretically by Einstein's field equations. Apart from black holes and wormholes, white holes are another solution to these field equations. What are these white holes? Just like white is opposite to black, a white hole will be opposite to a black hole in every sense. For example, no light can escape from a black hole once it is trapped inside it. No light can enter the other side of the white hole. It can only come out. This means that the white hole will look extremely bright and white. Russian theoretical physicist and cosmologist Igor Novikov was the first person to use the word white hole in 1964. According to scientists, a white hole is basically a time reversal of a black hole. For example, the event horizon of a black hole is a point of no return. Once it is crossed, nothing can escape. Similarly, the event horizon of a white hole is a boundary of no admission. Nothing can go beyond that point. The objects inside the white hole can go outside and interact with the outside world. But nothing can come back inside. Even though this is a solution of Einstein's relativity theory, no one knows how white holes will form in reality. Whether a thing like a white hole can exist or not, is a topic of discussion among scientists. Some scientists believe that when the Big Bang happened in the beginning of the universe, at that moment of creation, everything must have emerged from a huge white hole. Another theory is based on the idea given by Stephen Hawking. Stephen Hawking said that a black hole will eventually evaporate when radiation keeps leaking from it. Black holes are not eternal. They evaporate away at an increasing rate until they vanish in a gigantic explosion. But when a black hole evaporates, what will happen to the information inside it? What will happen to the matter inside it? Quantum theory has a fundamental law which states that no information can be lost. It is called the no-hiding theorem. According to the no-hiding theorem, if any information vanishes from a system, it must be existing somewhere else in the universe. Theoretically, if all this matter, all this information is getting sucked into a black hole, after the black hole vanishes, it must be getting spit out somewhere. And it must be happening through a white hole. Based on this argument, many scientists say that a white hole is formed when a black hole dies. But we don't have any substantial information about how a black hole dies. On the other hand, some scientists argue that it is theoretically impossible for a white hole to exist because it violates the second law of thermodynamics. As you must have read in school, the second law of thermodynamics states that entropy cannot decrease in any system. For example, the way a paper shredding machine shreds the paper which increases the entropy of the paper, in the same way, the black holes shred everything in the universe. The black holes swallow all the planets and stars and only the radiation remains. This increases the entropy of the entire universe. But if you try to imagine that it is happening in reverse, that the entropy is decreasing, this is not possible. And if white holes exist, then essentially, they will do the same. That's why they cannot exist with this logic. But despite this, some scientists believe that not only white holes exist, but in 2006, scientists saw a vision of white holes. On June 14, 2006, a space satellite named Neil Gehrels Swift Observatory captured an astronomical event. Scientists saw an explosion of a white light and it suddenly disappeared. This event was named GRB 060614. It was a gamma-ray burst. Gamma-ray bursts are basically very energetic explosions that are observed in distant galaxies. Usually, these events happen when a black hole swallows a big star. You can see very bright explosions of light. But in this case, no evidence of a star was found. So, it was hypothesized that it was an observation of a white hole. Since then, we haven't seen any such events again. And that's why white holes are only a theoretical thing. But the thing to note here is that black holes were also theoretical things at one time. But then, they were practically proved one day. So, it's possible that the same thing will happen with white holes in the future. The same thing can be said about wormholes. The most interesting news about the existence of wormholes is from 2015. When scientists created a magnetic wormhole, so, till now, we were talking about wormholes in the sense of gravitational force. But if we talk about magnetic force, scientists have already been successful in creating wormholes. What does this mean? There are two ends of a magnet, friends. One is the North Pole and the other is the South Pole. We all know that two ends always stay together. Even if you break a magnet into two pieces, the two poles of both the pieces will still remain. What did scientists achieve by using special materials? They separated the two poles of the magnets. They put an invisible gap in between. Basically, the magnetic field of one magnet went inside one end of the wormhole and came out from the other end. You can see its visualization here. The left image shows a device that was created by the scientists. It separated the two poles of the magnet. So, this device is basically working as a wormhole for the magnetic field. We can see this device with our eyes, but if you look at the magnetic fields in the right picture, you will see that there is one pole of the magnet on one side and on the other side, there is another pole separated from the other. Just like a wormhole in space will bend the space-time curvature, this wormhole here worked to bend the magnetic field. To make this magnetic wormhole, a high-temperature superconducting material was used. Its name is yttrium barium copper oxide. It was placed in a liquid nitrogen bath for this experiment. Finally, viewers, I would like to say that even if the existence of wormholes is not proven in the future, it doesn't mean that we can't find other ways to travel faster than light. Theoretically, many other solutions are proposed. One of them is Alcubierre drive. It was proposed in 1994 by theoretical physicist Miguel Alcubierre. The idea here is that there will be a spacecraft that can travel at a speed faster than light. But how will it be able to do it? It will be able to do it by contracting the space-time curvature in front and expanding the space-time curvature behind it. Theoretically, another solution of Einstein's field equation is presented here by Alcubierre drive. It will be very interesting to see what other solutions are proposed in the future of these field equations, and what practical things can be derived from them. I hope you will like and share this video. See you in next great video. Take care of yourself.